everyone. So this is a lecture of the visual bone. Make sure that you are taking notes and that at the end of this that you do label those diagrams that I passed out today in class. So the long bone structure. Long bone includes your femur, your humerus, your ulna, your radius, all of those bones. The middle portion of it, which is where like dogs bite, that they're going to hold on to the bone, this is called the diaphysis. That PH makes the F sound, so diaphysis. And this is the shaft, the middle portion. It is covered in a protective structure called the periosteum. It's a very fibrous tissue, and this is what's going to help keep all of the bone together in case if there is a fracture, as well as keep the bone safe and protected. While the bone is very tough, it is always nice to have a nice layer over it to make sure that the calcium is staying where it should be and that it's not dissolving. So the diaphysis made primarily of compact bone, meaning that it is very dense. So the tissue is extremely tightly packed. Dense is something that is, it's got a lot of stuff in a small area. So I always remember that the diaphysis is dense. I remember those two D's. So the diaphysis is dense. And in the middle of that dense bone, if you remember we snapped open the bone, you can see the medullary cavity. This is going to be where our bone marrow is. Now, in adults, that bone marrow is going to be yellow, so it's more fatty. But this middle portion does have an inner lining as well, called the endosteum. And that medullary cavity is where a majority of that marrow is going to be. So this is your nice diagram. Go ahead and take a few moments. If you want to pause the video and write everything down, you can. The diaphysis is here in the middle. With that compact bone, you can see how it's really dense in there. That's what helps give the strength of the bone. And then the yellow marrow in the medullary cavity. So then the long bone structure, the epiphysis are the two ends. So that's here and here, the epiphysis. There we go. There and there. They extend the shape, and these are going to be the two parts that are going to connect to other bones. So we have the proximal, which is going to be closest to the body. So if I look at my humerus here, this is going to be the proximal, and that's going to be the distal end of my humerus. So these two areas are covered in articular cartilage so that they can connect with other bones, including the clavicle, scapula, ulna, radius, and they are made up of spongy bone. So they have lots of air spaces very similar to a sponge, and they can also contain lots of extra blood. So this is where our red bone marrow is going to be found in a majority of adults, here along within the axial skeleton. So epiphysis, I think about the ends, epiphysis, end, diaphysis is dense. So the diaphysis is dense bone, epiphysis, those are the ends, and those are spongy. You can see the little holes in the end of the bone there. And then we also have a close-up on the actual bone. We have an osteon, which is going to be a little circle that we see developing in the bone. So we've got a nice like piece of pie of the actual bone here. You can see that in this area, in the compact bone area, we have several small circles that make it up. One circle is called an osteon. Remember, osteo refers to bone, so you should not be surprised when the osteocytes are the ones that are creating the osteons. We also have like veins and arteries that are running through here along with nerves in order to feed the bone. So while bone is really dense and it's tough and it's hard and full of all this calcium, it is also a living structure that is constantly needing blood supply. So those osteocytes, they need to be fed. We have the osteocytes here that are building the osteons with the central canal in the middle. Don't worry about this slide. We're going to skip past it. Now we're looking at the microscopic bone. So this is going back to the osteon, that one chunk that we see within the diaphysis. The central canal is going to be threaded with arteries and veins along with nerves, which is why when you break a bone, it really hurts yourself. So those concentric circles, meaning that there are many layers of the circles, those are of calcium carbonate and calcium phosphate. So we've got those strong minerals that are surrounding in the osteon that give it its shape and its definition. The osteocytes, osteo meaning bone, cyte meaning cell, those are going to be found in the small spaces called the lacuna. So lacuna, I believe that's rooted in like Spanish for moon, like luna. So in these areas, we've got like almost what looks like crescent-shaped cells. Those are the osteocytes. And they are going to be the ones that are spitting out the matrix, spitting out the calcium carbonate, the calcium phosphate in order to help build the osteon. So here we have a nice transverse section of a bone. You can see that we have these central canals running here with the blood vessels and the nerves. And then this is one osteon. We have many osteons that make up the bone. And within the osteon, we have the osteocytes that work together in order to lay down that structure. And that is it for the notes. If you have any questions, you can always ask me when you're doing your Simon Says rotation with me.